the first of the Breakthrough Prize's $3 million gifts to our laureates. To present it, please welcome multiple Emmy nominee and neuroscientist Dr. Mayim Bialik and the president of Tech Incubator Y Combinator, Sam Altman.
As a neuroscientist who plays a neurobiologist on TV, it is a great honor to be here tonight among so many brilliant minds and to stand with Sam and help honor an ensemble cast that has earned the Breakthrough Prize in fundamental physics.
For me, the key to tech investing is having a long time horizon. If one day cities will be built from scratch by solar-powered robots, and they will, then I want to invest today. But the physicists we are honoring tonight are working with a time horizon that makes mine look kind of lame. These guys are really taking the long view. Plus, they're looking backward.
They built WMAP, a NASA mission that looked as far back in time as it's possible to see.
With WMAP, we see a picture of the universe as it was 300,000 years after the Big Bang.
We're looking at the universe's baby picture. This room, our entire universe, is filled with the leftover light from the Big Bang. There are a few hundred photons in every little cubic inch of this room that are photons that have been traveling for 13.7 billion years. It's the oldest light.
Looking at the light, we're looking back in time. Nature has provided us with a time machine, and that is the speed of light.
That radiation has streamed across the cosmos to us.
It comes to us, and we just record it as a photograph, essentially.
We designed WMAP to go study the temperature fluctuations of this light and to characterize the pattern on the sky because we knew that the pattern would unravel the recipe for the universe.
You're measuring the relative temperature of 2 points of the universe. You're measuring, is that one 1/10,000th or 1/100,000th of a degree hotter than that one over there? To work with the level of precision that we wanted across such large areas of the sky, we really needed to go to space. And that's why we built the satellite. That's why we built WMAP.
You spent many years of your life designing and building and testing this instrument.
Yes, launch day, the only other thing it compares to is giving birth.
It was 1.5 million miles from the Earth. It took a year of data to actually put together a high-quality map of the sky.
To my surprise, we saw what we expected to see. With WMAP, the tools we had were good enough to explain what the universe looked like 13.8 billion years ago, really for the first time with high precision. But just like with a baby, the genes are there already. All the stuff that's gonna make it into an adult are there. Because if you have one region that's 1/10,000th hotter than the other, by the time you get to today, that has grown to be a supercluster of galaxies that contains stars,
Planets and us.
Somehow we seem to have done it. We think we understand the physics that happened in the universe's first moments.
Here it is, the infant universe.
For detailed maps of the early universe that revealed the evolution of the cosmos and the fluctuations that seeded galaxies,
The Breakthrough Prize in Fundamental Physics is awarded to the WMAP science team and its leaders, Chuck Bennett, Gary Hinshaw, Norman Jarosik, Lyman Page, and David Spergel. Congratulations.
The W in WMAP stands for David Wilkinson, one of the founders of the experiment. Professor Wilkinson passed away before the completion of the mission, but lived long enough to see its first dramatic results.
It's not at all obvious that we humans on a tiny planet in the enormous vastness of space could possibly answer questions about the universe as a whole. But WMAP surveyed the patterns of the oldest light, and we used the laws of physics to deduce from these patterns answers to our questions. The result is relatively simple, but strange. Atoms make up only 5% of the universe. Dark matter and dark energy dominate. Science has let us extend our knowledge of the universe to far beyond our physical reach. There is still much we do not understand, such as the first moments of the universe, so there will be new breakthroughs in the future. Thank you.